In this video, we're going to be going over the practice problems for Module 2, Part 2. So we're looking at calculating z-scores, and then we'll also go through some examples for constructing a distribution based on a certain set of criteria. So we'll start with calculating z-scores, and we have 3 examples given a certain mean and standard deviation. I think it is easiest for me to calculate these using my whiteboard. So we're gonna shift to that. Taking note that our mean is 21. So we'll just write those over here. Mean was equal to 21 and the standard deviation was equal to 6.46. And then our raw scores, just to note for our examples, were 9, 22, and 34. So we want to be able to calculate z-scores for each of these. And we can do that by using our formula, which was z is equal to the raw score minus the mean divided by standard deviation. So in our first case, we could say z is equal to 9, which is the raw score, minus 21, which is the mean, divided by 6.46. Right, and we can kind of just follow this pattern for each of our examples. And then we can do a simple calculation on our calculator. You can use your phone if you actually have a calculator. That's cool too. Just remember that you want to do the operation in the numerator right before you divide. Otherwise, you're going to get some wonky numbers. So hopefully my calculator worked correctly. And we can round our first z-score to negative 1.6 or negative 1.86. Okay, if we did 22 minus 21 divided by 6.46, we should get a z-score of 0.15. And then the last one, we should get a z-score of 2.01. Okay, so then we can look up these values in our z-table to get our estimated percentiles. Okay, so our first z-score for a raw score of 9 was negative 1.86, which means we're going to go to our negative z-table. Okay, we can see up on top, we've got our second decimal point, and on this side in this first column, those are going to be our first decimal point. So if we're at negative 1.86, we just line those up. So we go all the way across, and then we go all the way down. And that ends up giving us that percentile there. Okay, so we could express this as a probability between 0 and 1, saying that we have a probability of 0.0314, or we can note this as a percentage and say that 3.14% of all data values lie at or below 9 in this distribution. We can do the same thing for our second example. For a raw score of 22, we had a z-score of 0.15, which means we're looking at the positive z-score table. So I'm going to get rid of those markings. We'll go to our positive table, and we're looking for a z-score of 0.1. So that's going to tell us we start here. And then we're going to a 0.05 in our hundredths place. So we get a z-score of 0.5596 or 55.96%, meaning that 55.96% of all of our data points in this distribution lie at or below 22. Our last example was for a raw score of 34, and we calculated a z-score of 2.01. So again, we're going to be on our positive table, 2.0, and 0.1 is up here, or 0.01. And that gives us a z-score of 0.9778 or 97.78%. So we could say that 97.78% of our data points in this distribution lie at or below 34. Okay. So those are our first examples. And if you go to the next slide, we can see that our answers do check out. Next, we're going to go over our examples for creating a distribution. So as we went over in lecture, right, we have knowns, and then our unknown is kind of the statement of that's going to be indicating where exactly we're looking in our distribution. Okay, so the first thing we need to start with is to actually draw a distribution. Okay, so I'm going to go again back to my whiteboard, and I'm going to erase all of this. So we have a nice clean slate. So I draw my distribution, and I never draw perfect bell curves, so we're just going to roll with it. Okay, there's a couple ways that we can label our distribution. You will have this on the exam, so you can feel free to use whichever method you remember best. Where you can either list the center as 0 or the mean. If you want to write mean, you can actually put the value of the mean, whichever. And then the first way that we can label this is just by using standard deviation units, in which we could say this is +1 standard deviation, +2, +3, -1, -2, and -3 standard deviations from the mean. We could alternatively use the actual units of measurement that we are looking at. So in this example, I had indicated that the dependent variable, or the variable we're actually measuring, is hours fasted. Okay, and I noted that our mean, I'll write this over here, our mean was 23.5 hours, and our standard deviation was 5.8 hours. Okay, so the important thing to remember is that these are actually in the units of measurement. The values in the x-axis that I wrote initially are standard deviation units. Okay, so if we wanted to use our units of measurement, that also works out fine. Either method will end up giving you pretty much the same results. And in this case, we could say 23.5 goes in the center. Moving in this direction, if we add 1 standard deviation, which is 5.8, you basically in your calculator can put 23.5 plus 5.8. You should get 29.3 plus another 5.8. you get 35.1. Plus another 5.8, you should get 40.9. We could also go in the minus standard deviation direction. So instead of adding your standard deviation value, you'd be subtracting, in which case we'd say 23.5 minus 5.8 gives us 17.7, minus 5.8 gives us 11.9, minus 5.8 gives us 6.1. Okay, so again, just to note, our standard deviation units are this top row, and our actual units of measurement, I'm just going to call that M, are the second row. Okay, so these are all in hours. These are all noted as standard deviation units, or we can call them z-scores, because if you recall from lecture, one z-score is equal to one standard deviation. All right. Now we've got the setup. Our question, or our unknown, is asking, what is the probability that a person fasted for 12 hours or less? So there's a couple ways we can go about this. We can either say, where is 12 in our units of measurement, which we could say is closest to 11.9. So it would be feasible to draw a line relatively close to 11.9, or -2 standard deviations from the mean, right? Where X is representing, or our raw score is 12 hours. The other way we can go about this is calculating the z-score, right? So z equals our raw score minus our mean divided by our standard deviation. Okay, and then we end up getting -1.98. So then we can look up this value on our z table, in the negative z table specifically. Let me get rid of these markings. Okay, so negative z table, we're looking for -1.98. So we've located -1.9, move our way across the table till we get to 0.08 column. And we can see that we've got a percentile, or probability, of 0.0239, which we could also say, right, this shaded region is equal to 2.39%. Whoops. Okay, or we can notate it as a probability as 0.0239, whichever one works. Both of them are correct. Okay, but the point that we want to, highlight how this example is different from just calculating z-scores is that, yes, we could find the location of the raw score either by using the units of measurement or the calculated z-score. But with the question in hand, it's a probability that a person fasted 12 hours or less, indicating that we want the area under the curve to the left of the raw score. This is different from the next example, okay, where we're looking at the probability that a person fasted between 18 to 30 hours. So again, move this upwards. So we have a distribution, right? I'm just going to label this one this way because it's the fastest. -1, -2, -3. Okay. Just a reminder, our mean is 23.5 and our standard deviation is 5.8. And we are looking for a probability between 18 and 30 hours. So we need to calculate the z-scores. Okay, so the z for, I'm going to put 18 as a subscript. We would have 18 minus the mean divided by the standard deviation. Okay. That will give us a value of 0.95 or negative 0.95. And then our z-score for the data point of 30 same formula, right? And we should get a positive z-score of 1.12. So then we look these values up on our table, right? Or first, let's actually fill this in. So 1.12, right? If we're going off the z-score, sure, let's say it lands there, right? The z that we look up in the table is going to give us this entire area. Okay. The z for 18, however, we had a negative 0.95, so we're relatively close to 1, right? And that's going to give us the area to the left of that point. Or the probability we look up will be the area to the left of that point. So what we're trying to aim to do in this is to find this middle portion. Okay, so the percentile or the probability of that yellow portion is going to be equal to the probability we get for the z-score at 30, or for the raw score of 30, minus the percentile that we get for the z-score at 18. So that's kind of our formula that we're working with. Okay, so we can fill this in here, and we can say for 30, we have a z of 1.12. So if we go to our positive z-score table, right, we've got 1.12. And that gives us 0.8686 or 86.86%. Right, and then we're going to subtract the probability that we get at negative 0.95. So we go back to our z table. We'll do the negative one this time. And just for reference, our 0.5 column is this one. And we're looking for negative 0.95. So we end up with a probability of 17.11%. When we subtract these, we can get our percentile that lies in that middle section, this one up here. Okay. So 86.86 minus 17.11 is going to give us a probability of 69.75%, meaning that the chances that we could randomly pull a data point out of this distribution, right? We have a 69.75% chance of drawing somebody between 18 and 30 hours of fast time. Okay. So let's do one more example. Again, we'll have our distribution here. We label it accordingly. And now we're looking at the probability. So let's go to our PowerPoint real quick. Now we're looking at the probability that a person fasted more than 36 hours. So we want to look at 36 hours and above. Okay, so we can calculate our z-score for 36 minus our mean divided by our standard deviation. And that gives us a z of 2.16. Okay, so on our graph, we can say, this is pretty close to +2 standard deviations, right? And we want the probability of more than 36 hours. Remember that when we look up a percentile on our z-table, it's going to give us the area to the left of that raw score. We actually want the area to the right. So in this instance, our target area is going to end up being 100% minus whatever we get for our z-score whenever we have a point of 36. So we can look this up on our z-table, right? Looking 2.16. So we're going to the positive one. Okay, so 2.1. And then column for 6 is over here. Right, so we're looking at a percentile or percentage value of 98.46%. So when we say 100, or this entire distribution, minus that 98.46%, we end up getting 1.54%. So this is what lives in this yellowed area here. So we have a 1.54% chance of randomly choosing somebody out of this distribution who fasted more than 36 hours.